Hi everyone, this is Matt Touchot with Intro Stats, and today we're looking at a problem from my book, Intro to Statistics for Community College Students, and this is section 4F, number 32. So section 4F, number 32. Let's read the question together. We want to know if the state a home is built in is related to the size of the home. A random sample of homes in the U.S. was taken. Click on Edit Data in Stat Key and type in the following contingency table. Do not forget to include spaces after the commas. Use a 5% significance level and a randomized simulation to test the claim that the state is not related to the size of the home. Okay. So I think this might be actually a preloaded data set, but we may have to type it in if it's not. So we're using Stat Key to do a randomized simulation. Now we're looking at two different, looks like they've classified the size of the home as either large or small. So again, they've taken something, the size might have been a quantitative variable, you know, if it was like square meters or square feet or something, but or if it was volume of the home, it might have been cubic meters or cubic feet, or but they've classified it as large or small. So they've taken a quantitative variable and made it into a categorical variable. So this is two categorical variables that we're trying to see if they're related. We're testing the claim that they're not related. Remember, not related is going to be the null hypothesis. Related is going to be the alternative. Okay, so let's take a look. So if I go to Stat Key, now the test for association, the categorical association test, is this one. It says chi-square test for association. It's kind of at the bottom middle of the Stat Key menu. I'm going to click on that. Now I'm looking for, and it might be preloaded here. Yeah, it is, homes for sale, size by state. Yeah, it was already there. Okay. So we can see that they really had homes from 4 states, and they classified the homes as either big or not big. All right, so those are there's our data. Okay, yeah, it's the same numbers they had here in the problem, so I think we're okay. And there's my chi-square test statistic, 2.313. Okay, again, if you want to see the expected counts, we could look at here. The top number is the observed counts, and the expected counts would be these ones in green, or the middle number right here. So it looks like 4 of the expected counts were 5.8 and 4 of the expected counts were 24.3. So all of the expected counts did go over 5, though barely. So again, we're getting really close to that 5 borderline. Okay, so now I want to kind of see, is this significant, right? Notice again, the null hypothesis is that there's no association, right? No association, they're not related. So the size of the home is not related to the state. The alternative would be they are related, or there is an association. Okay, so I'm going to simulate the null hypothesis. It's going to calculate thousands of chi-square test statistics based on the premise that there's no association between the variables. There we go. Remember, we learned a categorical association test is a right tail. So we're going to click right tail. Did they tell me in the problem? Yes, they did. They want us to use a 5% significance level in the problem. So I'm going to put in 0.05 in the tail. So here's where our tail begins. Okay, so this would now be a critical value right here, or an estimate of the critical value. Remember, your critical value when you do this may be a little bit different than my simulation right here. Remember, your random samples are not the same as my random samples, right? Sampling variability. So this number might be a little tiny bit different in your simulation than it is in mine. Don't worry. But basically, we're seeing here that the tail starts at about 7.477. So my test statistic needs to be 7.477 or bigger to be considered in the tail, to be considered significant. Is our original sample significant? No. Well, chi-square 2.313, that's our test statistic. 2.313 is way over here. It's not in the tail. That means our sample data does not significantly disagree with the null hypothesis. It also means that our observed counts are really not significantly different than our expected counts. Okay, now let's get the p-value. The p-value would be the probability associated with this original sample data, so this original sample chi-square test statistic. You're going to take that, 2.313, and put it in this bottom box right here. So I'm going to put in 2.313. I'm sure we're going to get a pretty big p-value here. Once I put in the original chi-square, there's my p-value, 0.541. Again, you may get a slightly different number in your simulation than mine. It's okay. I bet we're both in that 50% mark though. So 0.541, 54.1% p-value. That's a gigantic p-value. It's definitely a lot bigger than our 5% significance level. So this could just be sampling variability. If the null was true, the sample data could have just be the result of sampling variability. So if you remember, a high p-value means it could be sampling variability, and we are going to fail to reject the null hypothesis. So we're failing to reject the null hypothesis. Now, the claim is that they're not related. So the claim was the null hypothesis. So when we failed to reject the null hypothesis, we actually failed to reject the claim. So our conclusion? There's not significant evidence. Remember, high p-value is not evidence, not significant evidence to reject the claim that the state a home is in is not related to the size. Okay? All right. So, one thing they did ask, I think in the question, they said, what was the degrees of freedom? So in a contingency table, you do the number of rows minus 1, so 2 minus 1, times the number of columns minus 1, 4 minus 1. Don't count the totals. So we had 2 rows not counting totals, 4 columns not counting totals. So degrees of freedom would be 2 minus 1 times 4 minus 1, which would be 1 times 3 or 3. We get a degrees of freedom 3 there. Okay, all right, I hope that helps. So this again was section 4F, number 32. This is Matt Touchot with Intro Stats.